Dr. Strange, you think you know how the world works. What if I told you the reality you know is one of many?
Teach me.
Cool. Let's do it. Internet, welcome to Film Theory, debunking magic one fairy at a time. There's a hole in the hat for the rabbit. The cards behind his hand. Duh, there's two people in the box. He's walking on plexiglass. I mean, honestly, the only magic trick I truly can't figure out is how Chris Angel still has a career. In short, everything can be explained through science, which brings us to the subject of the day, Doctor Strange. Also known by its other titles, Now You See Me 3, We Promise Jesse Eisenberg Isn't in This One, or its other title, Inception. In the trailer, we see a whole bunch of crazy images. Doctor Strange shooting out rings of green lights from his hands, manifesting crystal walls, lassoing light whips. We even see entire cities shifting and protruding out of each other, upside down, sideways, and diagonal. Seriously, it's like Marvel watched Inception and we're like, what, one upside down city? Try 4! That is the power of Disney, bitch. But here's the rub. From the get-go, Marvel has sold its more fantastical elements as pure science. Captain America is the result of a science experiment gone wrong. The Hulk is the product of gamma radiation. Ant-Man reduces the empty space between atomic particles, something we've already debunked. Even Thor, complete with his rainbow bridges, is explained away as highly advanced technology.
Your ancestors called it magic, and you call it science. Well, I come from a place where they're one and the same thing.
In fact, this focus on science over quote-unquote magic has been confirmed by none other than the head of Marvel Studios himself, Kevin Feige. Quote, "Are you watching the Cosmos series? That's magic. It's unbelievable. If somebody knew how to tap into that stuff, what's the difference between that and magic? Sure, in the comics, Doctor Strange derives all his powers from magical and mystical entities, but Feige has stated the film version will be a departure from the comics, explaining the Doctor's powers not with magic, but science." Again, to quote Kevin Feige, there are a couple of lines in Thor basically saying that magic and science get to a point where what's the difference? And we're continuing that in Doctor Strange. So by coming down firmly on the side of science, Feige has revealed that actually everything in Doctor Strange can be explained through reason and logic. But holy rusted Iron Man, guys, how do you explain away light shields and upside down cities? Even Feige acknowledges that Doctor Strange doesn't quite know himself. To use one more quote from the guy, particularly for a character like Strange, who goes from a man of science to a man of faith and who traverses both worlds. And sometimes there won't be an answer. Sometimes he'll want an answer, how is this happening? And nothing. Well, unlike Feige and the rest of Marvel Studios, I, Matt Pat from Film Theory, am not going to be leaving you hanging anymore, Benedict Cumberbatch. Explaining the strange magic of Doctor Strange is my challenge today. And believe it or not, all of it is possible with the power of quantum mechanics. So before we hop into analyzing the movie, let's start with a quick quantum mechanics overview, teaching you in a few seconds concepts that overturned centuries of established physics knowledge. Basically, up until 1900, scientists believed the universe ran on pretty standard laws. Jump off an object and fall to the ground. Push an object to the right and it moves to the right. Ask J.J. Abrams to direct a movie and he'll fill it with a bunch of lens flares and some big twists in the final half hour. These are the fundamental laws of nature. But at the beginning of the 1900s, scientists discovered exceptions to the established rules, specifically subatomic particles like electrons and neutrons, the building blocks of atoms. And these particles often contradicted the physical world as we understood it. One of the biggest developments came in 1909. Basically, this was the year when Albert Einstein proposed the wave-particle duality of light. In order to explain some pretty funky results scientists were getting when testing light in the lab, Einstein proposed that maybe light sometimes acted like a wave, which is how everyone thought of it at the time, but then also other times acted more like a particle, just like an electron or a proton. It's a bit confusing, but it's important to understand for today's episode, so let me quickly explain the difference. Imagine a calm pond with leaves on the surface. When you drop a stone into the water, it makes a series of circular waves, which, when they reach the leaves, cause them to bob up and down. But otherwise, the leaves stay in the same position. They don't actually follow the wave. It's the same thing with the water particles. The wave moves through them, but doesn't actually carry the particles along with it. This roughly illustrates the difference between waves and particles. A particle has mass and other measurable properties like charge, while waves don't. Waves typically, but not always, need to move through some other medium. That's why, for instance, in space, no one can hear you scream. There's no sound because there's no air for the sound waves to move through. But that brings us back to light. Basically, light has shown itself to possess energy and momentum, which are properties of particles and not waves. And yet, light has no mass, which is like rule number 1 for anything that behaves like a particle. So basically, Einstein said, why not both? In what is very obviously a bad rendition of a German accent, which in turn prompted physics to turn on its head. In 1929, Gilbert Lewis named these massless light particles photons, and thus, quantum mechanics was born. So why do we need to cover all that? Well, because photons and their crazy properties are the basis of Doctor Strange's magical powers. Throughout the film, Doctor Strange uses light both as an offensive weapon as well as a defensive tool, manifesting mandalas of light as a shield to move and repel objects. It's crazy, right? Well, maybe not so much. You can, in fact, move objects using only light. You know how wind blows into a sail and pushes it forward? Well, you can actually do something similar with light because, as we just discussed, light has momentum. So let me introduce you to solar sails, large, lightweight, mirrored surfaces currently being used in space to move objects long distances. Basically, the light hits one side of the sail, which has a mirrored surface. That mirror reflects away the photons coming from the sun, but in the process, the momentum of the photons is transferred to the sail, just like wind on a boat. And in space, where there's no friction to slow you down, those small bits of momentum start to build up. And that's only one way that light can move objects. There's also what's known as the photophoresis effect. When an atom is heated on one side by photons, the gas molecules on that side of the particle get super excited. Woo, we're in the sunlight, we're gonna get a great tan. That causes them to move faster. And as a result, they bounce off that side of the particle's surface at a higher velocity, creating a force that pushes that atom away from the light. And this isn't just speculation. Scientists have recently tested the photophoresis effect on tiny objects, moving nails, beads, and even blocks with nothing but the power of light. So how does this apply to Eggs Benedict? Well, throughout Doctor Strange, we see this on a massive scale. For instance, in this moment from the trailer, we see the villain Caecilius harness a ball of light that essentially pushes the particles of Doctor Strange and the rest of the building outward. In other words, the front half of Benedict heats up really quickly from the intense light, and the photophoresis effect does the rest, causing a ripple effect as objects repel outward towards lower illuminated areas. What's happening on the atomic level is that the gases around the Benedict Cumberbund face particles are getting so excited with this intense light energy that they start hitting him with an intense amount of velocity. So much velocity, in fact, that he gets sent flying against the wall. But photons aren't just limited to moving matter, they can also create matter. That's right, objects made from massless light particles. Seems like it makes no physical sense, and yet, in a recent study, Harvard and MIT students managed to coax photons to binding together into molecules. Per scientist Mikhail Lukin, quote, "They created a special medium in which photons interacted so strongly that they began to act as though they had mass and banded together," end quote. The end result? Light creating three-dimensional structures like crystals. Sound familiar? Well, it should, because Doctor Strange is filled with crystal imagery. For instance, when Doctor Strange first meets the Ancient One, the first thing he sees is light coming from a crystal-like pattern.
This doesn't make any sense.
Well, actually, Doctor, it makes perfect sense. The photonic light tangles itself up with the atoms in the air, so much so that the properties of the atom get passed on to the photons. At that point, the photons basically become an atom, creating solidified light. A light crystal. What you're walking through is a light crystal that is being shattered. And if that just sounds like a weird theory, a weird scientific theory, it's actually happened in real life, as a group of scientists back in 2013 already created solidified crystals made purely of light. Forget Swarovski and its silver crystals, I want my light crystals. And mind you, this isn't the only crystal image that we see in Doctor Strange either. When Strange is practicing alone in this chamber, the first thing he magically forms is, you guessed it, a crystal wall. It's no accident, Marvel did their homework on this one. And I don't know about you, but knowing a little bit more about the science behind these seemingly magical moments makes me appreciate the scenes in the movie a whole lot more. That's just commendable filmmaking, guys. Well done. And that finally brings us to the moment that we've all been waiting for. How do they get those cities to topple over one another in a strictly scientific way? The key here is to listen to what the Ancient One tells Dr. Strange when they first meet.
We harness energy and shape reality.
She claims that there are two keys to their powers: harnessing energy, which they do via photons, and then secondly, shaping reality. This is a very careful choice of words. The Ancient One doesn't say that she changes reality, just that she's shaping it. Thus, reality doesn't change, only your perception of it does. It's the essence of a magic trick. From the vantage point of the audience, the bunny really does come out of the hat. The card disappears in midair and the woman is cut in two. Chris Angel gets paid to do whatever Chris Angel does. The magician has shaped reality, so the audience is led to believe in the impossible. So how do you shape reality to create upside down and sideways cities? The key here is in the Marvel logo, which for Doctor Strange looks like a pattern you'd see in a kaleidoscope, right? Well, you are right. The patterns you see in a kaleidoscope are one version of what are known as fractals. Fractals are basically geometric patterns that infinitely repeat themselves at smaller and smaller sizes. Think of a snowflake and how the same shape is repeated over and over in every section of the flake. Well, Marvel is dropping hints all over the place that fractals power the universe of Doctor Strange, popping up all over the movie's trailer. When Doctor Strange enters the Ancient One's lair, he steps across a platform modeled after a T-square, one of the most famous recurring fractal patterns in history. The light mandala the Ancient One first shows Doctor Strange, yet another fractal repeating circular images. Even the roof above Strange's head in the scene where he wields his light whip is a fractal. And it's these images that serve as the biggest clue as to how Doctor Strange pulls off his greatest trick. Because you know what else creates naturally occurring fractals? Crystals. We already know that Strange's crystals create repeating images, as we see in this scene. Look closely and you see that there's not just one, but multiple Benedict Cumberbatch reflected in the surface. Be still, my nerdy Sherlock-loving heart. The upside-down and sideways cities are the exact same, only at a much larger scale. These cities aren't actually upside down or sideways. They only appear that way through a refracted, repeating image within a crystal. It's important to note that the upside-down and sideways cities aren't any different from each other. They're exact replicas of one another. The same buildings, the same cars, the same landmarks can be found in each city. That's because there's actually only one city. Only our perception has been altered, so we see multitudes of intermingling cities. This also explains why the cities start to distort at the edges of the image. These distortions prove that what we're looking at aren't actual cities on top of each other, but merely reflected images of one city. Reality hasn't changed, only its perception has. That being said, how Doctor Strange can interact and battle in a crystal refraction is perhaps a theory best saved for another day. Or who knows, maybe they explain that one in the movie. Full disclosure, this is being written and edited the week before the movie comes out, so I haven't seen it yet. Thusly, if this scene is explained in the movie and this is all redundant information, then, screw you. Screw you, Marvel. Thanks for not inviting me to an early showing of the movie. You invited Markiplier. Does he have a film channel? No. Who has a film channel and is talking about your movie? Me. Giving you lots of promotion for your movie for free? Me. But no, let's not invite MatPat, who has to rewatch and rewatch again the trailer a bunch of times in order to analyze the science of the movie. It's fine. Not bitter. So hopefully they don't explain this in the movie. Otherwise, this whole episode might be a moot point. Could be super embarrassing for me. Alright, I digress. Let's wrap this thing up. Long story long, if there's one thing this video has shown, it's that Kevin Feige's original statement is 100% correct. That even though we can explain away the magic of Doctor Strange using crazy quantum theories, the science behind it all is indeed magical. And impressive. Whoever the science researcher is at Marvel, props to you, man. In fact, you know what? Here, actually, let me look it up. I just went on a rant about being overlooked, so I'm not gonna overlook you. Science consultant for Marvel Studios, Adam Frank. Astrophysics professor at University of Rochester. You, sir! Your name may be overlooked by the millions of moviegoers waiting for that post-credit shawarma joke, Adam, but today, the millions who hopefully watch this episode will come to know the true magician behind the scenes, and that is you. So thank you, Adam Frank for bringing accurate science to some of the world's biggest films. For that, you might not win the Oscar like my boy Leo, but instead let me give you the next best thing. The Theorist Seal of Profound Worth. Hashtag thank Frank. Wear it with pride, Adam, as you've done your part in making the world a slightly smarter place with science. And that is pretty darn magical. But hey, that's just a theory. A film theory. And cut. Congratulations, you're now smarter about quantum mechanics in the Marvel Universe. Impress your friends with those knowledge bombs, why don't ya? Now, if you watch this long, it means you probably like the Marvel movies. And if that's the case, then you've probably really liked the Deadpool movie. Based on the number of views it got, you may have even seen my Deadpool video about how to kill the guy. In case you missed it, I'm gonna leave a link to it right here. But you know what you probably haven't seen yet? Wisecrack's video on the philosophy of Deadpool, which not only has one of the most clickbaity thumbnails in the history of YouTube. I mean, I love you guys, but seriously, bright yellow and click me? You've done me so proud. But also has some awesome analysis of the movie, tying it to classical literature and dissecting what it means not just for the Marvel Universe, but what Deadpool means for the entire movie industry these days. It's incredible. I was watching this video and I'm like, yeah, that is awesome. That makes so much sense, which is usually a good reaction to have when you're watching a video. And that's why I really like sharing their stuff with you guys, because I love their videos, and I think if you like this channel, you're gonna like their videos too. These are guys that deserve way more love on their videos, so please click right here on Deadpool's left butt cheek to check them out. Deadpool will thank you for it. He'll also enjoy you rubbing your mouse over his left butt cheek. It will be very pleasurable to him. He'll probably make some sort of sexual innuendo. Anyway, with that, I'm done. Next week, we move away from Marvel and move on to Pixar for a Wall-E theory that will decimate you. I'm excited about it. I will never watch that movie the same way again, and honestly, it was my favorite Pixar movie to begin with, so I'm excited about that one. Hopefully, we'll see ya next week. Post-credit shawarma joke. I don't know what the joke is. I, once again, was not invited to the early showing, so there you go.